Our planet is a world of water. From the vast emptiness of space, Earth shines like a brilliant blue marble. It is a jewel suspended in the dark cosmos. This vibrant blue is the signature of our world. Let us travel back in time. We journey to an era more than 4.5 billion years ago. This is the Hadean Eon. The name comes from Hades, the ancient Greek underworld. The young Earth was a chaotic and violent place, constantly bombarded by debris. For millions of years, Earth remained a dry and desolate planet. The surface was far too hot for liquid water. The planet was trapped in a runaway greenhouse. The first theory looks to the Earth itself. As the planet's interior churned and heated, gases trapped within the rock were released. Volcanoes on the early Earth would have been incredibly active, spewing enormous clouds of gas into the atmosphere. This water vapor slowly accumulated in the atmosphere, just waiting for the planet to cool. The second theory looks to the heavens. The outer solar system was a much colder place where water ice was abundant. Comets are often described as dirty snowballs, time capsules from the birth of our solar system. A relentless bombardment of these icy bodies delivered water to the young, dry Earth. Each impact was like a cosmic water delivery. For liquid oceans to form, one crucial thing had to happen. The planet had to cool down. High in the cooling atmosphere, the first microscopic droplets of liquid water began to condense. The steam was starting to clear, and for the first time, liquid water was about to linger on the surface. The moment finally arrived. This was the first drop of rain on planet Earth. Soon, a drizzle turned into a downpour. This was not a gentle shower. It was a deluge of epic proportions, a planet-wide storm that would last for thousands, perhaps millions of years. Eventually, in some sheltered, cooling crater, a drop of rain fell and did not boil away. Across the globe, this was happening everywhere. Water began to pool in the lowest-lying areas. The Great Basins were full. The planet was no longer a glowing red ember. It was a blue planet. At the equator, water received the most direct sunlight and grew warmer than water at the poles. Applied on a global scale, this gave birth to the first ocean currents. A slow, grand circulation began. The oceans changed this by becoming a great distributor of energy. They acted like a global heating and cooling system. This cold, salty, dense water became heavier and began to sink, cascading down into the deep ocean basins. This sinking of water at the poles was the starting point for a vast, interconnected system that would link all the world's oceans. As this deep water flowed through the abyss, it eventually began to warm and rise back to the surface. The primordial sea was now a vast, planet-sized chemical laboratory, teeming with dissolved minerals. In this rich broth, simple inorganic molecules would have spontaneously begun to form more complex organic molecules. Energy was plentiful. Sunlight streamed down from above, geothermal heat from hydrothermal vents, and lightning from the atmosphere. One of the earliest ideas imagines a warm little pond, where the sun's energy would have concentrated organic molecules. Another theory looks to the skies. Comets and asteroids may have delivered the building blocks of life ready-made. One of the most powerful theories takes us to the deep, dark abyss and the strange world of hydrothermal vents. However life began, the first organisms were simple, single-celled microbes, likely deriving energy from chemical reactions. A revolutionary innovation appeared. A new type of microbe evolved to harness the sun. This was the invention of photosynthesis. As cyanobacteria spread across the globe, they began to release vast quantities of oxygen gas, fundamentally transforming the oceans and atmosphere. Around 541 million years ago, something extraordinary happened. The oceans suddenly erupted with astonishing diversity. Trilobites scuttled along the seafloor. Anomalocaris prowled as a strange swimming predator. The first chordates emerged. Predation became a major driver of evolution, forcing animals to develop defenses and new forms of locomotion. The Ordovician period saw the rise of vast reefs, creating complex three-dimensional habitats. The Silurian and Devonian periods are called the Age of Fishes. The first jawed fish appeared, sparking incredible diversification. The most devastating was the Permian-Triassic extinction, wiping out over 95% of marine species. Phytoplankton produce at least half of the oxygen in our atmosphere. Every second breath we take is a gift from the ocean. The ocean remains the master regulator of our climate, preventing extreme temperature swings and making vast regions habitable. The ocean is the source of all fresh water, constantly refreshing the supply that all terrestrial life depends upon. For as long as our species has existed, we have had an intimate relationship with the ocean. Our dependence on the ocean has never been greater. It is the backbone of the global economy. Over 80% of the ocean remains unmapped, unobserved, and unexplored. Today, for the first time in its long history, the ocean faces a new and unprecedented threat: us. The dissolved CO2 is making the seawater more acidic, catastrophic for organisms that build shells or skeletons. Overfishing, pollution, and warming are systematically dismantling the web of life woven over 500 million years. The ocean is the blue heart of Earth. It has been beating for more than 4 billion years. Let us remember all that it has given us: the air we breathe, the climate we enjoy, the water we drink. We have the power to choose a different path, to become stewards of our blue planet. Let us resolve to protect this ancient, life-giving world of water, ensuring the heart of our living planet continues to beat strong for all generations to come.